Hello, and thanks for tuning in to a brief information session around Maths Pathway, a program that we are introducing at Scarborough State School for all Year 6 students in 2019. During 2018, our Year 6 students piloted the program for Semester 2, working very closely with Maths Pathway facilitators to ensure it was a smooth transition and implementation of the program across our maths curriculum for Year 6. The program has been a great success, and we'll talk about that a little bit further and how and what maths will look like in the Year 6 classrooms. How we think about maths has a great impact on our success in maths. So let's firstly just reflect on what it was like for you in the maths classroom when you were at school. Did you walk away into your adult life with an idea about whether you have a maths brain or not? What kind of feelings do you get when you get a maths question wrong? And do you believe that you can improve on your maths? Let's tune in now to this TED Talk by Joe Bowler around our mindset about maths and the way we think about maths and how we should be changing this for our students.
Hello. So I'm here to tell you that what you have believed about your own potential has changed what you have learned and continues to do that, continues to change your learning and your experiences. So how many people here, let's get a show of hands, have ever been given the idea that they're not a math person or that they can't go on to the next level of math, they haven't got the brains for it? Let's see a show of hands. So quite a few of us. And I'm here to tell you that idea is completely wrong. It is disproven by the brain science, but it is fueled by a single myth that's out there in our society that's very strong and very dangerous. And the myth is that there's such a thing as a math brain, that you're born with one or you're not. We don't believe this about other subjects. We don't think we're born with a history brain or a physics brain. We think you have to learn those. But with math, students believe it, teachers believe it, parents believe it. And until we change that single myth, we will continue to have widespread underachievement in this country. Carol Dweck's research on mindset has shown us that if you believe in your unlimited potential, you will achieve at higher levels in maths and in life. And an incredible study on mistakes showed this very strongly. So Jason Moser and his colleagues actually found from MRI scans that your brain grows when you make a mistake in maths. Fantastic. When you make a mistake, synapses fire in the brain, and in fact in their MRI scans they found that when people made a mistake, synapses fired. When they got work correct, less synapses fired. So making mistakes is really good. And we want students to know this, but they found something else that was pretty incredible. This image shows you the voltage maps of people's brains, and what you can see here is that people with a growth mindset who believed that they had unlimited potential, they could learn anything, when they made a mistake, their brains grew more than the people who didn't believe that they could learn anything. So this shows us something that brain scientists have known for a long time, that our cognition and what we learn is linked to our beliefs and to our feelings. And this is important for all of us, not just kids in math classrooms. If you go into a difficult situation or a challenging situation and you think to yourself, I can do this, I'm going to do it, and you mess up or fail, your brain will grow and more and react differently than if you go into that situation thinking, I don't think I can do this. So it's really important that we change the messages kids get in classrooms. We know that anybody can grow their brain, and brains are so plastic, to learn any level of maths. We have to get this out to kids. They have to know that mistakes are really good. But maths classrooms have to change in a lot of ways. It's not just about changing messages for kids. We have to fundamentally change what happens in classrooms. And we want kids to have a growth mindset, to believe that they can grow and learn anything. But it's very difficult to have a
Okay, we'll drop out of that TED Talk just quickly now so we can move on. However, growth mindset is one of the key drivers of the Maths Pathway program. We'll talk a little bit further about how this is incorporated into the day-to-day maths curriculum in your child's Year 6 classroom. To summarise, changing the way our students think about their maths ability, these were the key points that came up through that TED Talk, that all people are born with a maths brain, and there is power in making mistakes, and it does help our brain to grow. And there is that strong connection between how we feel about maths and how much maths we will learn. Moving on now, we will have a look at rich tasks and the part that this plays in the Maths Pathway program. This is an example of a rich task that students will participate in the classroom, and it highlights that maths is more than just logging online and accessing the Maths Pathway program. It involves problem solving and students each contributing in different ways to solve challenges in a hands-on, engaging way. You might like to pause this presentation for a brief moment and see how you can go completing the rich task by using only the addition, subtraction, multiplication and division symbols to solve the equation. So to recap where we are at so far in talking about the Year 6 maths curriculum at our school, incorporating Maths Pathway, you can see that growth mindset has a large place to play. You can also see that through rich tasks, maths is hands-on, engaging, problem-solving, and requires students to work together. Another element of Maths Pathway is maths mastery, and we're going to tune into another TED Talk around what maths mastery means and the importance of it.
I'm here today to talk about two ideas that, at least based on my observations at Khan Academy, are kind of the core, the key leverage points for learning. And it's the idea of mastery and the idea of mindset. And I saw this in the early days when I was working with my cousins. A lot of them were having trouble with math at first because they had all of these gaps accumulated in their learning. And because of that, at some point they got to an algebra class and they might have been a little bit shaky on some of the pre-algebra. And because of that, they thought they didn't have the math gene, or they'd get to a calculus class and they'd be a little bit shaky on the algebra. I saw in the early days when I was uploading up some of those videos on YouTube, and I realized that people who are not my cousins were watching. And you know, at first those comments were just simple thank yous, and I thought that was a pretty big deal. I don't know how much time y'all spend on YouTube. Most of the comments are not thank you. They're a little edgier than that. But then the comments got a little bit more intense. Student after student saying that they had grown up not liking math. It was getting difficult as they got into more advanced math topics. By the time they got to algebra, they had so many gaps in their knowledge that they just couldn't engage with it. And they thought that they didn't have the math gene. But when they were a little bit older, they took a little bit of agency and they decided to engage. They found resources like Khan Academy, and they were able to fill in those gaps and master those concepts, and that reinforced their mindset that it wasn't fixed, that they actually were capable of learning mathematics. And in a lot of ways, this is how you would master a lot of things in life. It's the way that you would learn a martial art. In a martial art, you would practice the white belt skills as long as necessary, and only when you've mastered it, you would move on to become a yellow belt. It's the way that you would learn a musical instrument. You practice the basic piece over and over again, and only when you've mastered it, you go on to the more advanced one. But what we point out, this is not the way that a traditional academic model is structured, the type of academic model that most of us grew up in. In a traditional academic model, we group students together, usually by age and around middle school age and perceived ability, and we shepherd them all together at the same pace. And what typically happens, let's say we're in a middle school pre-algebra class and the current unit is on exponents. The teacher will give a lecture on exponents, then we'll go home, do some homework. The next morning we'll review the homework, then we'll get another lecture, homework. That'll continue for about 2 or 3 weeks, and then we get a test. And on that test, maybe I get a 75%, maybe you get a 90%, maybe you get a 95%. And even though that test has identified gaps in our knowledge, I didn't know 25% of the material. Even the A student, what was the 5% they didn't know? Even though we've identified those gaps, the whole class will then move on to the next subject. Probably a more advanced subject that's going to build on those gaps. It might be logarithms or negative exponents. And that process continues, and you immediately start to realize how strange this is. I didn't know 25% of the more foundational thing, and now I'm being pushed to the more advanced thing. And this will continue for months, and it'll continue for years, all the way to at some point I might be in an algebra class or a trigonometry class, and I hit a wall. And it's not because algebra is fundamentally difficult, or because the student isn't bright. It's because I'm seeing an equation, and they're dealing with exponents, and that 30% that I didn't know is showing up. And then I start to disengage. And to appreciate how absurd that is, imagine if we did other things in our life that way. Say home building. So we bring in the contractor, say, told we have 2 weeks to build the foundation, do what you can. So they do what they can. Maybe it rains, maybe some of the supplies don't show up, and 2 weeks later the inspector comes, looks around, says, okay, the concrete's still wet right over there, that part's not quite up to code, I'll give it an 80%. Say, great, that's a C, let's build the first floor. Same thing. We have 2 weeks, do what you can, inspector shows up in 2 weeks, it's a 75%. Great, that's a D+. Second floor, third floor, and all of a sudden while you're building the third floor, that whole structure collapses. And if your reaction to that is the reaction that you typically have in education, or that a lot of folks have in education, you might say, maybe we had a bad contractor, or maybe we needed better inspection, or more frequent inspection. But what was really broken was the process. We were artificially constraining how long we had to do something, pretty much ensuring a variable outcome. And we took the trouble of inspecting and identifying those gaps, but then we built right on top of it. So the idea of mastery learning is to do the exact opposite. Instead of artificially constraining when and how long, fixing when and how long you work on something, pretty much ensuring that variable outcome, the A, B, C, D, F, and do it the other way around. What's variable is when and how long a student actually has to work on something, and what's fixed is that they actually master the material. And it's important to realize that not only will this make the students learn their exponents better, but it will reinforce the right mindset muscles. It makes them realize that if you got 20% wrong on something, it doesn't mean that you have a C branded in your DNA somehow. It means that you should just keep working on it. You should have grit. You should have perseverance. You should take agency over your learning. Now, a lot of skeptics might say, well, hey, this is all great. Philosophically, this whole idea of mastery-based learning and its connection to mindset, students taking agency over their learning, makes a lot of sense, but it seems impractical. To actually do it with students, it seems like every student would be on their own track. They would have to be personalized. You'd have to have private tutors. You'd have to work worksheets for every student. And there were experiments. These aren't new ideas. There were experiments in Winnetka, Illinois, 100 years ago, where they did mastery-based learning. And they saw great results, but they said it wouldn't scale because it was logistically difficult. And the teacher had to give different worksheets to every student, give on-demand assessments. But now today, it's no longer impractical. We have the tools to do it. Students need an explanation at their own time and pace. Well, there's on-demand video for that. They need practice. They need feedback. Well, there's adaptive exercises. It's readily available for students. And when that happens, all sorts of neat things happen. One, the students can actually master the concepts, but they're also building their growth mindset, they're building their grit, their perseverance, they're taking agency over their learning. And all sorts of beautiful things can start to happen in the actual classroom. Instead of it being focused on the lecture, students can interact with each other. They can get deeper mastery over the material. They can go into simulation, Socratic dialogue. And to appreciate what we're talking about and kind of the tragedy of lost potential here, I like to give a little bit of a thought experiment. If we were to go 400 years into the past, to Western Europe, which even then was one of the more literate parts of the planet, you would see that about 15% of the population knew how to read. And I suspect that if you ask someone who did know how to read, say a member of the clergy, what percentage of the population do you think is even capable of reading? And they might say, well, with a great education system, maybe 20 or 30%. But if you fast forward to today, we know that that prediction would have been wildly pessimistic, that it's pretty close to 100% of the population is capable of reading. But if I were to ask you a similar question, what percentage of the population do you think is capable of truly mastering calculus, or understanding organic chemistry, or being able to contribute to cancer research? A lot of y'all might say, well, with a great education system, maybe 20, 30%. But what if that estimate is just based on your own experience in a non-mastery framework, your own experience with yourself or observing your peers, where you're being pushed at this set pace through classes, accumulating all these gaps. Even when you got the A, that 95%, what was that 5% that you missed? And it keeps accumulating all the way that you get to a more advanced class, and all of a sudden you hit a wall and you say, oh, I'm not meant to be a cancer researcher. I'm not meant to be a physicist. I'm not meant to be a mathematician. And I suspect that that actually is the case, but if you were allowed to be operating in a mastery framework, if you were allowed to really take agency over your learning, and when you get something wrong, embrace it, view that failure as a moment of learning, that number of the percent that could really master calculus or understand organic chemistry is actually a lot closer to 100%. And this isn't even just a nice to have. I think it's a social imperative. We're exiting what you could call the industrial age, and we're going into this, whatever, information revolution. And it's clear that some things are happening. In the industrial age, society was a pyramid. And at the base of the pyramid, you had a large pool of, you needed human labor. In the middle of the pyramid, you had kind of an information processing, a bureaucracy class. And at the top of the pyramid, you had your owners of capital and your entrepreneurs and your creative class. But we know what's happening already as we go into this information revolution. The bottom of that pyramid, automation is going to take over. Even that middle tier, information processing, that's what computers are good at. So as a society, we have a question. All this new productivity is happening because of this technology, but who participates in it? Is it just going to be that very top of the pyramid, in which case, what does everyone else do? How do they operate? Or do we do something that's more aspirational? Do we actually attempt to invert the pyramid, where you have a large creative class, where almost everyone can participate as an entrepreneur, an artist, as a researcher? And I don't think that this is utopian. I really think that this is all based on the idea that we let people tap into their potential by mastering concepts, by being able to exercise agency over their learning, that they can get there. And from when you think of it as just a citizen of the world, it's pretty exciting. When you think about the type of equity we can have, and the rate at which civilization could even progress. And so I'm pretty optimistic about it. I think it's going to be a pretty exciting time to be alive. Thank you.
And so to give a summary of that TED Talk and the idea around maths mastery, you can see that it's a switch from what traditional classrooms and traditional maths curriculums usually provide. The focus being more flexible about when and how long it takes to work on a maths concept, and being fixed on the idea of mastering that concept rather than moving on and pacing through maths concepts across a calendar or school year. To coincide with that, it's around having the grit and the perseverance and taking agency over your learning, linking back to the growth mindset that we had talked about earlier. So again, to highlight, the Maths Pathway program focuses on maths mastery for individual students. So moving on and having a little bit more specifically about what Maths Pathway looks like in a classroom. This is an example of a timetable and the way a teacher will plan out a 2-week cycle. So you can see the A and B on the left-hand side of the timetable represents week 1 and week 2 of the 2-week cycle. You can see that students over the 2 weeks will access Maths Pathways on 7 occasions to work through individual modules, focusing on maths concepts that they have yet to master. You can see that module work is broken up with a 10-minute energizer or brain break, and that links back to the rich task that we did earlier on in the session. You can also see that on Tuesdays, as the example, year level investigations occur, and this focuses on providing students with exposure and an opportunity to explore year level, that is, in this example, year 6 concepts in an investigation style. These are low risk exposures to the concepts where students are not assessed. And then finally, you can see at the end or nearing the end of the 2-week cycle, students participate in a cycle test. So that is a test where of the module work that they have completed within that 2-week cycle, and also a reflection. The reflection is a brief conversation with the maths teacher where students think back over the 2 weeks in the maths classroom and determine a suitable, appropriate goal for the next cycle. This may be specifically around mastering particular modules that they are finding challenging. It may focus on attitudinal growth mindset goal, or it may link to their bookwork and their presentation of their module work. This is a quick fly-through of the maths classroom and gives you a visual of the timetable that we've just discussed. Please note that all of these examples are usually not occurring at the same time. However, it is a nice visual to see the examples. Now, to have a look more specifically around what it looks like for a student when they're logging in to access their module work, this is an example of a student platform. You can see on the left-hand side that a student can access their results at any time and complete a diagnostic test to unlock more module work. The diagnostic tests occur in the classroom in test conditions. Now, the large circle in the middle of the page is the timeline. So this shows the students' effort, growth and accuracy of the current module or cycle. So effort and accuracy provide a growth percentage that students are working towards. 100% growth indicates 12 months learning within a 12-month period of time. On the right-hand side, you can see there is a parent platform, and I will show you in a little bit more detail about what parents can see. Just a reminder that students can access this platform at home, so they can complete module work at home, and parents can see how students are progressing with their maths curriculum from home as well. And down on the bottom half of the page, that is the specific module work. So you can see that students have access to 6 activities, and the detail there that a test is occurring on the Thursday the 8th of November in this example, and then the reflection will occur. So that allows students the opportunity to keep track of how they're pacing in preparation for the scheduled test. When you click on the results section, and this is something that parents can access easily, you can see that this is another example, and you can see that cycle 4 So that's again reminding you that's a 2-week cycle. You can see that the growth of cycle 4 is 200%. So 200% indicates 2 years worth of learning within a 12-month period of time. Now the growth percentage is a combination of effort, so how many modules have been completed, in conjunction with the accuracy of how many of those modules have been mastered, indicates the rate of growth. Here is another short video detailing what is involved in a maths pathway classroom, and it's a bit of a summary about some of the things we've discussed today.
It's like educational but fun at the same time.
We want them to have a growth mindset where they can challenge themselves, grow themselves and improve on themselves.
If you have a growth mindset, you can say, I will give it a try because I never know what I can do and what I can learn.
Being born good at maths is not a thing. And just because you're not great at maths now doesn't mean you can't be.
Maths pathway is different to a normal math class because you can challenge yourself at your own rate.
You do your level maths, you don't do the level of other people.
Even though each student is learning an individual program, they're learning the right program for them.
What we've been able to do is take students that are excelling in maths and keep pushing them to higher levels to be able to provide them with opportunities to excel.
The biggest challenge of being a teacher is catering for the different learning needs that we have within our classrooms.
So with a mix of student abilities, we start the year with a widespread, and because of the different engagement levels, we'd also end the year with a widespread.
So you were missing the top end students and often going too fast for the lower end students.
That wasn't working for our classes and it wasn't working at our school. So we decided we needed to implement something else, and Maths Pathway fit that bill. So now we have students learning at twice, 3 times, 4 times the rate they were learning previously.
In the beginning, all students undertake diagnostic tests,
which really goes through all the areas of maths and where they're sitting.
And then it sets you at your own level, so you're working at your own pace and your own smartness. If the module that you're working on is too easy, you can click this is too easy, it'll give you a harder one.
The questions get harder as they go on.
This then, at the end of the 2 weeks, would lead to a test that was individualised towards students.
If you get every single question right from that module that's on the test, you've mastered it.
We then have a feedback session where the student sits with the teacher one-on-one.
That individual feedback session is critical. It has to happen for every student, and that's the time when they can discuss with their teacher the work that went into that test and what possible changes they need to make.
And it's great to see students that would have traditionally struggled in a maths class saying, yes, I want to get more, I want to go better, give me some more modules, I really want to go and learn some more.
Students are engaged in their learning, they're motivated to learn, they're driven to learn.
You see whenever 2 students are working on the same module and they both get it right and they master it, you see the high fives happening.
With Maths Pathway, working at their own level, we're seeing 200, 300, I've even had a kid get 500% growth.
For most classes, they're around 150%. That means on average that class is learning 1.5 years worth of maths in 1 year.
Last year I did parts of algebra that was in year 7, and I did something that was in level 10 called inequalities that I mastered.
I hated maths, hated it so much because I was horrible at it. With Maths Pathway it changed. I went from E's to A's and B's.
My math teacher told me if I keep up this rate, then I can learn 2.5 years of maths in the 1 year.
Makes me feel smarter and more intelligent. Gives me the attitude to I can do it and no one can stop me.
This is going to have a radical impact on their future education and their employment opportunities.
I had 4 parents sit down in 4 different interviews and say to me, I don't care what you're doing, my student loves going to maths now and that's all that matters.
We're not so interested in being somewhere now as where you're going to, what's the journey for that learning.
You want to push yourself to get to the top.
If you have a growth mindset, you can try new things, and that's where your progress comes from, especially in Maths Pathway.
The most exciting thing about being a teacher is seeing the change in the students from child to adult, and it's an amazing transformation.
Well, I can't do this yet. I will be able to do this. there's no failure there, it's just that you're still on that journey to where you're going to in learning.
So that's a nice little summary of many of the elements that we have already discussed today as a part of this presentation. And you may have seen some familiar faces there, as Redcliffe High are implementing Maths Pathway in their maths curriculum for years 7 to 10 students. So there is a seamless rollover from our year 6 maths curriculum into the high school if your child is continuing over to Redcliffe High. Now, just going back to the parent platform that we discussed, which can be accessed from home when your child logs into their Maths Pathway on their device at home. So this is an example of one of the results pages that you can view to get an update on how your child is progressing during the cycle and through their maths curriculum. So one of the parts highlighted here is the level. So this is where you can see what level the module work your child is working on. So this is in this example, you can see that this student is working on year 4, year 5, year 3, and year 6 levels of work. And that is the analogy that we have where students are filling in the gaps of missed modules and mastering modules from previous years that they may not have necessarily mastered in a traditional classroom. Now, this is where reporting can be a little bit different to how we have reported previously. Maths reporting using Maths Pathways will take into account the students' growth and their Maths Pathway level. But we will talk about this a little bit further once your child kickstarts and gets on board. Now, to finish up the information session around the implementation of Maths Pathway in the Year 6 curriculum at Scarborough State School, you will remember that we discussed growth mindset and how this approach is used when implementing Maths Pathway. We also referred to the hands-on and engaging element of the rich tasks and how these are incorporated into the 2-week cycle. We also looked at maths mastery and how it differs to the traditional maths classroom and the flexibility around the time it takes to master the concepts rather than progressing through a school year. Well, then we've looked at the module work and what it looks like on the student platform and how students access modules one at a time when it is right for them. Now, you can access more information on the public domain listed on the screen right now, or feel free to contact me. I'm Callie Sparling. I'm the Deputy for the Years 3 to 6 students at Scarborough State School. My email address is cspar37@eq.edu.au. I'm really excited about Maths Pathway and what it can offer our students, so please don't hesitate to email me to ask me any questions that you might have. Thank you.